We're going to take a look at section 3.3, multiplying, dividing rational functions, and simplifying. First off, a rational number is a quotient of two integers. It's a fraction. 5 over 2, negative 1 over 5, whatever else you have. A rational expression is the quotient still, but of two polynomials. So all those functions we were dealing with before, they're going to be in our fractions. So maybe x squared plus 3x plus 5 over x minus 6. Something like that. Or even x minus 5 and then x squared minus 6x plus 9. Anything like that. When simplifying rational expressions, fact the numerators and denominators, then cancel like factors in the numerator and denominator. Okay, I can do that. Excluded values. These values make the denominator of the expression equal 0. And if our denominator equals 0, well, we can't divide by 0 because it will destroy the city. Pretty sure people will be angry at you. So excluded values are values that are not in the function's domain. Find the expression's excluded values before canceling factors. So the first simplify, it's already factored for us, which is kind of nice. This gives us x can't equal 5. This gives us x can't equal 0. Because again, 3x squared equals 0, divide by 3, square root. Here we have x minus 5, I guess can't be 0. So we add 5 to both sides, and that's how we got that. And then our simplifying, we can cancel out our x minus 5s. We can also cancel out 1x. So that becomes the only x we have. So when we write out our final simplification, we don't have nothing in the numerator, or else we wouldn't see it. We at least have 1, and then over 3x. These are our excluded values. That's our simplified rational expression. Now this next one has a little bit more. From that one, we can see that x does not equal 0, x can't equal negative 4, and x can't equal positive 4. Now, are there things we can cancel out? Yep, the x plus 4s. We can cancel out 1x, and we can divide 2 and 8 by 2. So, in the numerator, we have x squared and x minus 3. In the denominator, we have 4 and x minus 4. And that is our simplification and our excluded values. So let's do a little bit more, but now we actually have to factor. It's not done for you. We'll stop being lazy. So first, we take out our GCF in the numerator. So we're left with x squared minus 5x minus 24. We can take our GCF out of the denominator of x cubed. So we're left with x squared minus 64. And then we can completely factor it. For the numerator, we do our MA table. We want two numbers that multiply to negative 24 and add up to negative 5. That would be negative 8 and a positive 3. X is in front of them. We have our x cubed. And then x squared minus 64 is just a difference of squares. So we get that. So when it's all factored, that's what it looks like. So from this, x can't be 0. From this, x can't be 8. From this, x cannot be negative 8. Now we cancel out what we can. Well, the x minus 8's cancel out. 1x cancels out. So all we have left in the numerator is x plus 3. And in the denominator, we have x squared times x plus 8. That, along with our excluded values, are what we're looking for. All right, we got another kind of long expression here. Except we have to, well, not except, we have to take out our GCF. We're left with x squared plus 3x minus 10 over. We can take a GCF out of here, 9x squared. We're left with x plus 5. So the denominator is already factored. There's not anything else we can do. Numerator, we can. Because x squared plus 3x minus 10, we can do an MA problem. So it's x plus 5, x minus 2. So our excluded values first. X cannot be 0. X cannot be negative 5. Then the x plus 5s cancel out. 3 divided by 3 is 1, divided by 9 is 3. And we can cancel out one of the x's. So in our numerator, all we have left is x minus 2. In our denominator, we have 3x. That's our simplified version. Those are our excluded values. That's simplifying rational expressions. Multiplying rational expressions is very, very similar to what we just did. We factor numerators and denominators if possible, just like we do with simplifying. Cancel like factors in any numerator and denominator. So same thing. So if we're dealing with 2xy over z times 3x squared over 4yz. So we could multiply this straight across. There'd be nothing wrong with that. So we get 6x cubed y over 4yz squared. And then we start simplifying. 6 and 4 can both be divisible by 2. And we can cancel out the y. So we're left with 3x cubed over 2z squared. Now, we could have just canceled out the y's to begin with and divided the 2 and the 4 by 2. We'd end up in the exact same place that we are now. All right, so B is a little bit more like what we were doing with the simplifying. So 5x and x plus 3, that's factored. Now, x squared plus x minus 6, MA problem, it's x plus 3, x minus 2. Same for the denominator, it's x plus 1 and x plus 1 times. We can take an x out of the x squared plus x and get x plus 1. We can take a 5 out of the x minus 10. Oops, it's not 10 anymore. It would be 2. So it doesn't ask for the excluded values here, so we don't need to give them. So the x minus 2's cancel out. So they don't have to be in the same fraction to cancel out. Just one has to be in a numerator, one has to be in a denominator. One of the x plus 1's cancel out. The x plus 3's cancel out. The 5's cancel out. So all we have left in the numerator is x squared. All we have left in the denominator is x plus 1. That is our multiplying, our simplifying. Again, it's just like simplifying, except there's more to simplify. That's really it. All right, let's try another one. Obviously, got a factor first. X squared minus 49, that is a difference of squares. 4x squared cannot be factored. 18x cannot be factored. X squared minus 4x minus 21 is x minus 7, x plus 3. So what can cancel out? Well, we can get rid of 1x We can get rid of 1x minus 7, and we can divide 18 and 4 by 2. So in the numerator, we have 9 times x plus 7. In the denominator, we have 2 times x plus 3. And it can't be simplified any further. All right, division. So when we divide, we do our KFC, keep, flip, change. Keep the first fraction the same. Change it to multiplication. Flip the second fraction. If you flip the first fraction and not the second, your answer will be upside down. Still not bad. It's still getting a decent part of it, but it does make a difference. So we can factor out a 10 in our first numerator. 1 minus x squared, we want to take a negative out so that the 1 becomes negative and the x squared becomes positive. And you'll see why in a second. Another MA table. Two numbers that multiply to negative 4 and add up to positive 3. That would be positive 4 and negative 1. Our denominator, two numbers multiply to 4 and add up to 5, is x plus 4 and x plus 1. All right, we're not done simplifying, although we can stop. Because even though we can simplify x squared minus 1 or factor it more, they're going to cancel out anyways. Just like the x plus 4s are going to cancel out. So now what we have is 10 times x minus 1 over x plus 1. And we got to keep that negative somewhere. And the whole thing is just negative. You could put it with the numerator or denominator, but it's the same thing. So really, dividing is the same thing as multiplying, and multiply is the same thing as simplifying. So that's really all we're doing. Let's try another. So again, we start by factoring. I can take a 2x out of the first set. I'm left with x plus 3. I can do a difference of squares in the denominator. I'm going to keep a division for now. We got to make sure that we flip it later. And x plus 6, x minus 3 will factor from x squared plus 3x minus 18. Now that it's all factored, we will flip the second fraction once I get there. So we get x plus 6, x minus 3, and 12x cubed. Now the fun part, the cancel out stuff. Well, those x plus 3's cancel out, those x minus 3's cancel out. We got 1x that's going to cancel out. We can divide 2 by 2 and 12 by 2. So all we have left in the numerator is x plus 6. All we have left in the denominator is a 6 and an x squared. And that's how we divide rational expressions.